Hi everyone, I'm here to talk about Feed Deep Dive and delivering a retentive AI enabled experience. We'll talk about the role of quality, content understanding, reasoning, and user cohort deepening to take a launched AI feature at meta scale all the way to product market fit and then on the way to monetization and deep engagement. Just to take us back on Facebook's original journey, Facebook app was launched back in February of 2004, almost 21 years ago. We brought on photos, the news feed, Reels also back in 2022. And then in April 2024, we launched Meta AI on Facebook. And this presentation focuses on post-launch, how we built it up to product market fit. So let's take a quick demo on Facebook feed and how Meta AI plays a role here. So here's a particular post, a video about an athlete breaking the world record. And often the user wants to find out what are the details of the record or find similar other times that the athlete performed well. Or maybe you want to know how old the athlete was when they broke the record. Maybe you also want to follow more of the news of this athlete and more performances of the athlete and get updates on it. So Feed Deep Dive focuses heavily on this use case of info seeking and context enrichment. Often we have a scenario where we are on Facebook doing very well on social connection and also on entertainment, but Feed Deep Dive focuses front and center on info seeking and context understanding use case. So let's look at the journey of Feed Deep Dive. Feed Deep Dive launched back in April, and we launched in the US in English. Then a couple of months after that, we launched in Spanish speaking regions. And then most of last year was spent on deepening engagement and launching in lots of different languages and lots of different regions around the world. So the last year's journey was to just get launch and basic deep engagement for the users. This year, which is the focus of the presentation today, has been our journey on really focusing on quality, leveraging techniques like agentic models, reasoning, and then scaling this up by improving our latency, reducing our capacity costs, and still delivering a more and more engaging experience for the user. So that's hopefully you get a feel for how do we build out a launched product and take it all the way to product market fit out of this presentation. So what are the core challenges we've had in building PMF? I think the core challenges we need to solve is A, provide a very high quality experience each time the user comes to the applications. LLMs are well known for hallucinations and refusals and so on. How do we make sure that each interaction is high quality? Second is how do we do this at meta scale and continue to do it with a better and better latency? And then finally, with Feed Deep Dive, we have a unique challenge where Feed Deep Dive is a feature based off of Facebook Feed. Facebook Feed is one of the most successful and highly engaging products on social media. Each time we are taking the user out of Facebook Feed, we have to surpass the bar set by Facebook Feed. We need to provide more user value than the user would be getting on Facebook Feed. So we'll also talk about how do we achieve that. So let's focus first on quality and scale, and then we'll focus on the other aspects of product market fit. So let's look at a couple of case studies here. So this is a very typical post on Facebook app where you have a meme from a TV show, which has very, very limited context on what's going on. You have a few dialogues from the show. It's not exactly clear how this particular scene plays out and why it's important and pivotal to the story. So without a lot of context, the kind of prompts you end up getting is why rebook the flight? What is the rebooking fee? Taking it very, very literally. So here what's happening is you have the post. You often have video transcripts or image OCR that's available. But then if you can leverage things like content sentiment analysis, so looking at what users are talking about, how people are reacting, how they are sharing it, and then also extract the entities. So in this case, who's the actor, what's the title? So you use the entire post context, including the text and the multimedia, and triangulate that to come up with more context. In this case, if you look at the comments, and if you look at the actors and titles of the show and so on, you're able to then do an external web search to get a lot more context on possibly what the scene was about and why it was important. So on the left is the failure mode. On the right is where we start to see more context. The show is the summer I turned pretty, but it actually goes into, by using our external web search and actually figuring out which actors we were talking about, we are able to then figure out that this is a critical scene in the show, and it leads to a lot more rich kind of prompt enrichment, and also the responses are going to be much more engaging. So leveraging comments and leveraging actors and doing an external web search, now you have a much better response. So that was the role of context enrichment here. Let's take another one. This is a very ambiguous post. If you read through the text, a few people are mentioned and there seems to be an event coming up. That's all that's mentioned. But now if you look at the video, which we'll try to play here, there's a rooster at some sort of farm or some sort of building, not exactly clear. Now, if I throw this video to a visual language model or a multimodal model, this is the frame by frame summary I get. The frame by frame summary is basically talking about a rooster in a grassy field. That's all I'm getting. And the prompts I get is around roosters, breeding roosters, behaviors of roosters, how to be trained roosters, all that kind of good stuff. Unfortunately, it's completely missing the point. In fact, this post, if we go back to the post, is actually about Troy Wing posting about an equestrian event at their farm. Now, it's not exactly clear how we can get to that conclusion. The best we can do here is extract the people, the prior posts of the user, and look at other cultural understanding, so other contextual understanding about what's going on, and then apply step-by-step reasoning to figure out what's happening. So in this case, we look up a web search on the people mentioned. They happen to be equestrian trainers. Then we look up previous posts from that particular creator. We figure out that they usually post about their farm, which is an equestrian farm where they train horses and they train people to ride horses. Then you look at the recent events that are happening there, put all of that together, and then you're able to come up with the fact that this is actually an equestrian training where the people are coming to train customers for learning how to horse ride. And now on the right, you can see a few very good prompts. Even for a human being, that was extremely difficult because you don't have to go and verify and do a bunch of web searches to verify what's happening here and put two and two together. For an LLM, it's even harder. So by bringing a lot of these contexts and bringing reasoning step by step, we're able to get to a point. We're able to generate really good prompts and add huge amount of value that a user just scrolling through the feed would not actually realize. So now, if you look at the prompts of the video, once we can scroll up, you'll see the prompts are about equestrian lessons and other event details here. And you can check the event schedule and all that great things that can be served. Moving forward, that was all around context understanding and how adding more context was very valuable. So clearly more context is good, right? Well, what we realize is that what we are doing here is taking a heuristic-based approach where we are adding a few different predetermined context that can help us get to a better prompt or a better response. Now, there are some real challenges with this approach. There is only this much context we can stuff into the token window of the LLM. And even within that, there's a needle in the haystack problem. The challenge is the LLM doesn't really quite figure out which pieces of the context was most critical. Second thing we realize is there's a lot of API calls we are making here, which go unused. They bring context which we never use. And to also deal with the size of the token window problem or the context window problem, we end up summarizing a lot, which takes up even more capacity. And by the way, all of this takes up valuable time and makes the response latency longer and longer. And often users will not be willing to wait that long and they'll just abandon the experience and move on to doing other things on Facebook feed. So this is the problem with using traditional orchestration. What we can do is we can start to move to agentic approaches. An agentic model really has three key features. It leverages planning, then it does tool calling, and then it does reflection. So let's talk about how we are using this here. Whenever we come up with this situation where we want to generate prompts, we'll first generate a plan of what tools to call. And tools are just APIs. So in the case of the horse riding example, we would basically create a plan in terms of what sort of data points I want to reach. In that case, the example would be calling out and understanding who the people mentioned were, and also calling out to multimodal understanding. When we realized that the people and the multimodal was not working out or were not matching via the reflection step, we would then make further tool calls to be able to get similar posts from the author in the past, and then put all of that together, come up with a proposed response, reflect on it, and based on the reflection, if it looks good, then we show it to the user. So these are the three steps we introduced here. Of course, this is now bringing in latency, but there's a higher quality response that we are providing to the user. And when we talk about product market fit, I'll talk about trade-offs between quality and latency. Finally, let's talk about the role of auto judges. So here on the right, you can see an actual user complaint file. So users are able to upload negative experiences that they find on Facebook app. In this case, all they're complaining about is the fact that there's a question that's suggested as a prompt to the LLM by Facebook app. But when they click that, they don't find an exact answer. In this case, the LLM is equivocating because it doesn't feel like it has enough context to answer it. It's essentially what we would call a refusal. Now, refusals happen for various reasons, but these are the top 3 reasons why they happen on feed dive. Either there's just not enough context. There is context, but we had an infra failure while trying to generate the context and understand it. Or there's an integrity and safety reason for it. So these could be these are the common reasons. And in these cases, either we have to redo and retry, or in some cases, we just are not able to give you a good answer. So the way to tackle this is that we want to reduce the number of refusals, but because each time we show a refusal, it leads to disengagement and it breaks habits for the user and breaks effective trust and credibility of the product. So refusals are not great, and we need to find ways to reduce them. So this is a more traditional way that I'm going to talk about is the offline method of evaluating. We leverage production traffic. We write a few auto judges that evaluate whether the response was a refusal. We sample some of them using human raters, and then we do a comparative analysis. And whenever human raters and the automation differs, that becomes a sample for model improvement. Now, as you can imagine, this model improvement cycle is often going to take a few weeks to actually get to fine tune the model so that it's ready for an upgrade. So a few weeks is the timeline for improvement here, and often is not good enough because these prompts and responses are actually prevalent only for a few days at a time. So although it improves the quality of the model long term, it's not improving in the moment. So we need to be able to do this in the moment. Now, the way we do this in the moment is to run these judges all the time at scale for a vast majority of the prompts. And on Facebook app, we have a tailwind, which is that 5 to 10% of posts generate about 50% of the traffic. So if we focus on the top 5% of posts and make sure that for them, we actually give you a refusal-free workflow, we capture the refusals, use that as feedback, and push the feedback not to the prompt generation model, but to the prompt ranking model, which decides which prompt to show to which user at what time. So by giving feedback to the prompt ranker, we can actually start to downrank prompts that lead to refusals and make sure that prompts that are likely to give very good responses actually get higher and higher rank. So using that approach, we are able to build an online pipeline using auto judges. The next question is, how do we scale this up? And how do we scale up judges? And how do we scale up context enrichment? The one single answer here, apart from many, many tricks in the book, is actually smart caching. So going back to that power curve, we have about 5 to 10% of posts actually driving the vast majority, about 50% of the impressions and 30% of clicks. So if we can focus on the top 5% of the posts and make sure that the experience there is great, very, very quick, we have a better chance at making sure that the majority of the impressions are actually getting very, very quick responses, and also we end up saving the capacity costs of recomputing responses. Now, here we will see that there is a trade-off between latency and freshness, or latency, capacity, and freshness. How do we achieve an efficient frontier at this? What we can do is try to figure out what topics need a short latency or a short TTL, and what topics are able to tolerate a long TTL. So for example, sports and news require a very short TTL since the response is in a fast moving environment. Whereas for how-tos and recipes, which are extremely popular on feed and on feed deep dive, we have the luxury of having a much longer TTL. So by detecting the topic and actually looking at the intent, we are able to tune the TTL for these very well. We can also go one step further and on an online basis figure out what is the hit rate on the cache. And for topics that tend to have shorter TTLs, if the hit rates are higher, we can start to accelerate the eviction much, much faster and try to make sure that because they're heavily accessed, we try and go in the favor of freshness there and give up the latency. And as we will see, for our deeply engaged users, they're happy to trade latency in favor of freshness. Now, finally, let's talk about retention. So we're going to, in this part of the section, we are just focusing on how do we build product market fit and deep habits for the user. 4 steps here. Let's define the product funnel. Let's identify and understand key cohorts, identify key content types, and identify jobs that we are doing very well for the user. Let's focus on the first one. So defining the product funnel. If we are able to nicely define like things like click-through rates, deep sessions, weekly active usage, L7ness or L28ness, and find the right thresholds for when we think the product is doing well for certain users and not, we can then start to look at patterns that emerge out of this, and that helps us with the next three pieces. We want to also identify which users or which cohorts the product is doing extremely well. So looking at feed usage patterns, looking at feed deep dive usage patterns, and understanding which cohorts are more monetizable, we are then able to double down on this and leverage like deep neural networks for targeting. So giving these users who are getting value, similar such users to have more and more prevalence of the feature. And for users who are not getting value, we roll back or squeeze back the feature on an online model basis so that they can continue to get engagement on feed or reels and other offerings on Facebook app. And we only use the real estate required for feed deep dive on those users who actually are getting a lot of deep value. So this is a key step. Let's go one step deeper here. How we do this is to leverage U to U models or U to M models. U to U is user to user similarity. U to M is user to media affinities. So certain users will engage with certain media. Doing this on a real-time basis. So feature engineering in a real-time basis, constantly A/B testing, and also leveraging LLM extracted features. So now with LLMs, we can extract rich semantic and language features out of the experience and use that as part of our deep neural networks as well. So doing all of that, we are able to leverage ML targeting and ranking to get more and more focus out of the product. Finally, talking about the key learnings and future work over here. We learned that context is king, and we had the hunch that more context is good. But we learned that actually right context is even better. And finding the right context is actually key to the experience. Here we get a lot of tailwind from agentic models because they're able to get the right trade-off between capacity latency and the quality of the response. And finally, we always felt that speed wins. But for deeply engaged users, they're often willing to pay in terms of latency or waiting for a little bit longer to get high quality answers. I think these are the key learnings for us. What we are doing next from here is now that we have deep product market fit, we're exploring more use cases, and also moving on to monetization. So for monetization, we need to focus on key intents where monetizability is possible, contextual ad integrations, and for social assistance, really bringing in social graph understanding and also privacy preserving social AI so that we are able to leverage feed deep dive for social use cases as well. With that said, I come to my end of my presentation. Thank you very much.